Yeah, so last time we created the task handles for the world engine subsystem, and in this one we are going to continue from where we left and create the tasks themselves, right? So all of these tasks are around 8 plus this one 9 tasks, and we are going to create the private function prototypes right here. So what I'm going to do to make it easier, I'm going to open the same editor in a different in like a split view, split vertical, yeah, so that I can reference task handles. And also I can reference what else was I referencing? Yeah, the task handles themselves only. So let me close this, close that. Right, so these are the next thing is read inhibit switch task handle. So world engine read inhibit switch. I'm gonna move as fast as I can so that we cover a lot in a short time, if that's even possible for this software. Void const argument, right? Next thing is void world engine. There's a way to concatenate this world engine prefix using C, but I don't remember it right now, so I'll just type it. Activate board task. Okay, so I'll just write them for now. Void world engine deactivate board task. Void world engine read MPU 6050 task. Void world engine read magnetometer task. Void world engine, what is I reading? Read a DXL task handle. The last thing is void world engine read what? Sound sensors. So you realize that all these tasks are for reading. We are not doing any processing from them at this point. This is task read sound sensors task, right? So all of these tasks take a void const pointer, or a pointer to void const, if you like to hear it that way. Right, so what I want to do is make it look more professional, like the task name. You can call X task. What did you read? Board voltage task. I think it's fine. Okay, we'll deal with the aesthetics later. So the last task is the monitor task handle. Right, so I'm going to copy that, paste world engine monitor task, right? So the monitor tasks is nothing but a task that can be used to keep checking for remaining heap. That's what I intend for it to do. But anyway, we need a task to debug this thing. So world engine debug debug, whatever, debug, oops, debug. So void, it's taking a void const pointer to argument. So let's make sure you don't have an error to this point. Build it. Let's build and see whether we have anything missing, so that we don't accumulate a lot of errors. Right, that's fine. So no errors at the moment. So next thing is, now we create these tasks, right? Now I'll start with the debug task that will help me like print these values that I read on the monitor, serial monitor, whatever debug I use, which is I'm gonna use a serial monitor, which makes me need to activate the UART. Did I activate UART? Debug UART. So do I have debug UART? I should have it somewhere. Yeah, I have it here. So debug RX and TX. So this is connected to P11 and P12. That is P11 and P12. This is USAT 6, right? So let me see whether it does not have a conflict. USAT 6. Alright, fine. So enable asynchronous, and yeah, that should be fine. Update the code for initialization. I ignore that warning for now. So for critical softwares, every warning is supposed to be taken care of. Yeah, you cannot ignore anything for software that is going to fly miles or millions of miles or thousands of miles away from you. Otherwise you can't reach it. Okay, we are done generating that, so let's create the tasks. Right, so I always copy the template for the default task, which is, where is it? Yep, here it is. User code begin. So I'll put it right here. So these are my tasks. Okay, so tasks creation. You know what I'll do? I'll just make it visible. Tasks creation. Task creation. Copy that and paste it here. Okay. Let me just world engine tasks creation. Okay. So our first task is this. I'll copy this template. I don't want to type all of that anyway, so the name of the task is this debug task. Copy that, put it right here. So I realized I don't have the task handle for the debug task, so I'm just gonna put it here. OS thread ID debug task handle, right? So world engine debug task argument. I'm gonna delete this and that. User code and delete that. So a task is nothing but like just a subset of our endless loop. So we realize that we have an endless loop here, because once we are done initializing the hardware, the CPU will give all control to the FreeRTOS scheduler, right? And actually, I believe they tell us that when we are close to the main, they say that we should never get here as control is not taken by the scheduler or whatever. Yeah, so this is never called. So all those small while while one loops, infinite loops are in the tasks. That's the whole point. Okay, so you can, one thing I want to mention is that you see this OS delay, right? This is a SIMSYS. SIMSYS stands for the long it's a long abbreviation, so but for me to explain, I have to, it's a common microcontroller software interface standard, enables consistent device support. It's basically just an abstraction to, you know, the FreeRTOS primitives. So for example, one of them is the OS delay. Similarly, you can just use the normal RTOS stuff, so you can say vtask delay here and there will be no problem. Maybe PD2, PDMS, something PDMS to ticks, if I'm not wrong. 1, yeah, I think. Yes. So you can remove this. So what I'm trying to say is that we can use a primitive direct functions without using, I don't like using the SIMSYS abstraction layer. So yeah, that's the whole point. Anyway, next thing is now these tasks, how will they communicate? We have to achieve what is called the intertask communication, right? And the best method to achieve that for now is using queues, right? So this, let me start something to explain how intertask communication will be done through PDF. Where is it? Robot. Just a second. So those tasks are going to communicate through queue. So their producer tasks are the tasks that will read the sensors themselves. Then they send that data to the queue, and then we do what? We read or we receive from that queue, right? And then we operate on the queue. So how do I create a new document? Okay, new document. Use that one. Create new. Creating, right? So remove that to let's add a pen here. What am I doing? Pen. Yeah, replace the 7th tool with a pen. Okay, all right. So what I'm saying is we have a task here, we have a task here, we have a task here. All of these tasks will send to a given queue, right? Or okay, yes, and then we have tasks that, is that shortcut for this? No, we have tasks that consume. So one way you can do it is send all the data to the same queue, right, from the producer functions. You can send data here, you can send data here, and then you can consume it here, right? So one of the biggest problems with this architecture is what we call the risk condition. Basically, it's very hard to synchronize all of these tasks when you're using a single queue. So what I like to do, in this situation is have what I call event groups. So event groups are when you send this data to the queue. Remember, all of these are running at their own frequencies, taking different times to run. When you receive from a queue, basically FreeRTOS makes you, it pops out that item, it removes it completely from the queue. So if you have two tasks reading from the same queue, the second task, if this one reads first and then this one reads the second task will read the next item, and they won't read the same item. Or so I think. I have had this bug before. So what I do is I pick picking, like PEEK. So I pick an item here and I pick an item here, and then once this receiver or consuming tasks are done receiving, I set an event flag that says, okay, we are done receiving data from the queue. Then I can pop that item, and then I read the next item, right? Yeah, so that's one way of doing it. The other way of doing it is simpler, which is basically having different queues for different items, right? So you have queue here, queue there, and a queue here, and then you're receiving tasks or task reads from all these queues, read from that, read from that, and read from that. There's no conflict in that way. Yep. Anyway, so I'll create that task. So obviously documentation is an unavoidable part. So what does this function do? This task reads the data from sensors and sends it via UART for debug. Right, return nothing. What else? So parameters. I don't really need to. Let me just put it for completion purposes. Parameters is taking what parameter? Argument. So this is, how do I let's say parameter to the task, to the tasks, the task. Okay. World engine. Next is we have that. Just copy paste all of that. So debug task. The next one is read board voltage task. World engine, read board voltage, right? And then read inhibit switch. I don't even think I'll need this. Read inhibit switch. Next thing is activate board task handle. So activate board. So maybe later I'll arrange them in terms of priority or like functional semantic meaning, right? Debug task, deactivate board, read MPU 6050, right? And then we have to read the magnetometer. Okay, then we have to read ADXL. Read ADXL 345. So ADXL is a pure accelerometer, right? Does not have gyroscope, temperatures, all of that shit from other sensors. It's just a pure accelerometer. It can sense tilt. You can get a lot of data from it. Tilt, touch, double tap, single tap, etc. stuff. Read. Very nice. I am actually thinking of building a separate project just to demonstrate its powerful capabilities, right? You can build something like a footstep counter, or I don't know, something cool. Yep. What I know is that this I realize I can't talk while I type. This function reads sun sensors via ADC converters, right? Does not return anything. This task reads the ADXL accelerometer. Next, these tasks, what does it do? Reads the magnetometer. Do I have a GPS task? I just realized I don't have a GPS task. Reads magnetometer. And then these tasks, what does it do? Reads MPU 6050 IMU sensor. Deactivates task, deactivates the board there. MOSFET switch activates. So these tasks activates what? The board via MOSFET switch. I was saying something. I was saying the good thing is about these sensors, they are built specifically for some purposes, and you realize that sometimes you might use them for like a given function, but you won't be using them to their maximum. So you're still underusing them for some reason, and that thing really bothers me, because if I can extract the tiny feature from a chip, it's a joy, man, you know. Yeah, so I just said I don't have a GPS task for some reason. Should not forget that. OBC save GPS. Yeah, GPS here. Oh, do I have it? Just lost my thought process. Read GPS. There's no read GPS here. So I'm just gonna select all of these, put it down here, hold the engine, read GPS, right? Then we need its task handle. We don't have it, so OS thread ID, read what? GPS task, read GPS task handle. Again, keep constant builds so that you realize when the errors are there or not. So let's build it, and you can see we have a lot of errors. Where is this coming from? What? That's a very strange bug. Static void. What's this? Declared static but is never defined. Why? Okay, because I didn't have a semicolon here. Nice. All right, cool. Successful build. We can go on. Okay, so I'm thinking of creating the files for this driver, or for the drivers for these specific chips. Where is my notepad? All right, here it is. So we have, how many drivers do we have? We have 1, 2, 3, 4, 5. Do we need a driver for this? Yeah, 6. So modularization, we are going to put these drivers each in a different file, right? So under the core part, we come here to include. We open these two. Include will contain our header files. So I'll start with the header file for GPS. So GPS .h, right? And then I'll create new source file, MPU 6050.h. What else? New source file, header file, ADXL 345.h. Sun sensor.h. What else have I left? DS18B20, DS18B20, DS18B20.h. right? And then we create their corresponding source files. New source file, right? So let me just create the ds18b20.c, create new source file, gps.c, new source file, mpu6050.c.h, and then oops, new source file, adxl 345.c, 1 2 3 4 1 2 3 4 5 sun sensor. I've got the sun sensor, so new source file, sun sensor.c. right, so I'll just write the function prototypes for some of these drivers. So let's start with the GPS. I think GPS, so file, so I'm using the docsgen file form documentation format, so it becomes easier to generate automated docs, right? gps.c, that's the name of the file, brief what the file does, right? So this file is a header file, right? No, this is a sensor.c, gps.c, this is what I want here. This file contains the driver declarations, GPS driver declarations. Other, of course, it's me as far as I can see. There are a lot of there's a bunch of data you can include here, licenses, etc. What date is this today? 28th August. 28 what? 08 2025. That's the date this file was born. Nice. Oh, let's think about this. Oh, this is a C file definitions. So I need to open the gps.h, then paste this there, and change this h and change this to declarations, right? So yep, that's fine. I'll close these ones for now. I'm not writing them in this video. Close, save this, close that, and close that. GPS. All right, cool. So basically the first thing you need to do is include your STM header file, so that you have access to like primitive I2C, UART, etc stuff, F4 something, F401x.h, right? So I like to refer to whatever STM has done. If you look at your main.h, they have this HAL, right? So yep, that's what I need here, HAL. Right, so let's think about this. So GPS has two interfaces to communicate with OBC. It has the I2C or UART. Then it needs to read all those latitude, longitude, etc data packet and then transfer it to the OBC or the world engine. Then world engine will package it, right? So I think I have some data. Let me. Yeah. So just is that I wrote some packet that GPS can provide us with, which is right here. so that it becomes very easy to code it. Right, so I'm just gonna list it here for just a minute. So for example, the first thing is latitude and longitude, right? Then we have altitude, we have 2D fix, how many satellites are in the orbit, we have velocity, let me call it, we have ground speed, we have vertical speed. I just want to get everything I can from that GPS heading over, unless the GPS is not capable of giving me that type of data. We have the UTC, we have the GPS time, we have the date, this is the year, month and day, we have the pulse per second, we have the fixed status, we have the satellite tracking info, so number of satellites that we have in view. We have what else? Number of satellites used in solution, number of solution satellites. SNR, signal to noise ratio per satellite, and elevation. I need the elevation angle. Cool, so this is the packet, right? So it means I'm gonna create type def struct GPS packet type T. Right, okay, the first problem, this is an anonymous struct, so let me give it a name, PS packet type, right? Of course, don't forget to document this thing. So at brief, this struct defines the GPS data packet, right? Just want to put it in the middle. Yeah, that one is fine. So these are float what? Float lat, float longitude, float altitude, float what? 2D fix is like let me use a unit 8T fix. I'll check this, I'm not sure about it. The next thing is the ground speed, so it's gonna be a float ground. I'll call it velocity. Float vertical speed. Float what? Heading over ground. Let me use an int16 for that. Heading is like the direction you're going to, right? Like angle. Int16. Let me use int. I'm not sure that it's going to be a signed or an unsigned int. What? Heading. GPS time is usually in 32T. GPS time in epoch things, it can be converted anyway. You will 32T date. Pulse per second is an integer, I think. PPS. Next is what? Fixed status. So you int 8T fix status. Number of satellites obviously uses at least 4 per session. 3 for 2D space and 4 the one for like 3D stuff. Number of sats. You int 8T. Number of solution satellites. Elevation angle. So float elevation angle. So how do you document structs or the elements of a type def? So I'm going to refer to some code I've written before. Why is that code? Okay, let's go to our Chrome and go to GitHub. I'll go to flight software. Just go to like previous src type def. This one has no type mpu.h. I did not document this thing for some reason. Anyway, normally let me just use my brain here. Normally it's something like this, and then that for the oxygen. So latitude, so this is GPS latitude. So I won't waste time like writing all of this. I'll just do that later, maybe at the end of the video, so that we focus on the code in this one. etc. That's how you do it. So when you automatically generate the documentation, it just knows. It knows. Yeah, what's what. All right, so we have this packet. Now, I want to hide the interface to this file by using what are called opaque pointers, right? So opaque pointers are a way of hiding implementation details from the user or from the code that uses it. So, are they really necessary? Opaque pointer. But generally, you just define. I'll just say type def a pointer to the GPS type, right? So GPS, I'm not sure, GPS packet type T pointer to that, right? I'm gonna call it a GPS packet PTR, right? So we don't have to type this pointer or anything, we only have this guy. Okay, so what functions are we gonna need for the GPS? The first thing we're gonna need is check now, are we using I2C or UART, right? So we have to define something here. Let's say define GPS use UART. Let's say that is a 1. Define GPS use I2C. They can't be one at the same time. I don't know whether that chip can handle that, or maybe it routes the data to both UART and I2C interfaces or whatever. But I want my software to be reliable, so I will just say here that just set this set to 1 if UART, if GPS, set to 1 to activate GPS I2C interface, right? And then this other one will be set to 1 to activate Cubesat interface, right? So I'll just deactivate this for now. I have the packet, I have the type def, then let's activate GPS. So brief this function activates GPS. So since we're in the header file, we just write the function prototypes for this function, for this driver. So for void GPS activate. So you see my naming, you see how my naming is. I'm starting with like the the module name. This will become very, very useful when you start debugging and searching for like a given subsystem. So you just search GPS and then list all the GPS. You can select very easily instead of having it search in other words or in words of the functions. So GPS activate, what does it do? Takes nothing. Okay, then void GPS deactivate. It takes nothing also. What else do we need to do with the GPS? Is read latitude and longitude. So void GPS read. So normally a GPS gives us an nmer sentence, right? So we need GPS get. Let me use read info. No, GPS read info. Let's see. GPS read. Okay, read data. Let's say read data. Then what happens when you read data? This function will take the nmer sentence. Okay, we'll check whether anything is available on the UART. Read the nmer sentence, and then they will decode that data. So we need a void GPS decode nmer, right? So what does this take? Should take a char pointer, right? And that char should be a const char pointer sentence bucket, right? So this one will read, package it into a char pointer packet, then pass it to this nmer. Then this decode nmer will decode that packet and feed those data types into this guy, right? What I'm thinking, other thing is we can get. So it means this one returns like a char pointer. Now that will go out of scope. So let's just have a void for now. We'll think out the details when we are writing the actual implementation in the C file. So GPS, we can get the time. Read time void GPS reset void GPS what read. I think that's fine. Let's have this for now. We'll see about the other functions when we get the hardware. Cool. So that's that. And the GPS.c we include here we'll include std int h and string. I know I'll need them anyway at some point. So GPS.c include GPS.h. Right, so we have access to all of these functions. Alright, so the video is again long. So what I'm gonna do next video, we'll write the implementation of those functions for this module. Right, so that's it for today, and I'll see you in the next one. I'm trying to move as fast as I can for this software part, because time is not on my side a lot. So yeah, if you can contribute, or you can do something on the project, if it's open source, so you feel free to contact or just hit me up on GitHub, email, etc, and I'll be happy to have you on board. Yep. Right, so see you. That's it.